Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Actually, I am reviewing the electrochemistry, and last class I have discussed effect of concentration on the EMF of a cell. Now I will continue, and now I am going to discuss cell reaction in equilibrium. As for example, Zn plus copper ion, Zn solid plus copper ion, Cu2 plus, it gives zinc ion plus copper solid. Already this reaction I have discussed. This is the reaction at equilibrium, means half cell oxidation, half cell reduction. If you will add, then you will get net cell reaction. That is the zinc. It will oxidize and it will give Zn plus 2 electron. And copper ion, it will take 2 electron. Cu2 plus 2 electron, it will convert to Cu. And if you will add both, then 2 electron will be cancelled. Then left side Zn solid plus copper ion will remain, and right side Zn2 plus copper solid will remain. Means Zn metal converts to Zn ion after oxidation, and copper ion that converts to copper metal after taking the electron. Then these two are half cell reaction. First reaction is half cell oxidation. Second reaction is half cell reduction. And if you will add both, then you will get net cell reaction. And for this reaction, E cell is equal to 0, because reaction is at equilibrium. At equilibrium, E cell is equal to 0. Then according to the Nernst equation, E is equal to E naught. E cell is equal to standard means E naught, standard E cell, minus 2.303 RT divided by NF log Kc. Then here at equilibrium, E cell is equal to 0. Then standard E cell will be 2.303 RT divided by NF log K. That also you can write, that is equal to 0.0591 divided by N log Kc at 298 Kelvin. Already I have discussed. After putting the value of R, T and F, you will get 0.0591. Then now E cell is equal to 0. Then standard E cell will be what? Just you can say reverse it. Means standard E cell minus 2.303 RT NF log Kc, that is equal to 0. Then what is a standard E cell? Then standard E cell will be just minus 2.303 RT divided by NF. That to take to the, you can say, left side. Then you will get standard E cell is equal to minus plus 2.303 RT divided by NF. Means minus will become plus, because E cell is equal to 0. And just you reverse it, then you will get E cell value. And after putting the R and T and F value, you will get 0.0591. Only n you don't know what is the value of n in general. Actually, in this case, n is equal to 2. What I have given example, zinc plus copper ion. Zinc plus Cu2 plus, that is equal to Zn2 plus copper. In this case, n is equal to 2. But in general, n value don't know. That's why leave it like this. Then after putting R, T and F value and multiplying it with 2.303, you will get 0.0591. Correct? Then standard E cell value will be 0.0591 divided by n log Kc. When ln you will convert to log, then you have to multiply it by 2.303. Then at 298 Kelvin, standard E cell is equal to 0.0591 divided by n log Kc, where Kc is equilibrium constant. Here Kc means, you understand, concentration of product divided by concentration of reactant. Correct? Because now this reaction you are considering at equilibrium. That's why now you are using the term Kc. Kc means equilibrium constant. Correct? Equilibrium constant. C means concentration actually. Concentration at equilibrium position. Then Kc is here equilibrium constant. Now next I am going to discuss relationship between free energy change and EMF of a cell. This is very important relation. Many numericals are asked on this relation. Then its relation is minus delta G is equal to NF E cell. Minus delta G is equal to change in free energy. Free energy means available energy to do the work. Then minus delta G is equal to NF E cell. N is number of electron. F is equal to 96,500 Coulomb. Faraday. F means here Faraday. Then minus delta G is equal to NF E cell. E cell, that is the potential, cell potential, E cell. And same things, if you will consider all the things at a standard condition, then now minus delta G you can write standard delta G, standard subscript 0 you can write. Then minus delta G standard, that is equal to NF E cell. Now it will come standard E cell. That is a minus delta G or minus delta G standard, that is equal to NF standard E cell. Now next relation I am telling you, that is also very important. That is a relationship between free energy change and equilibrium constant. So now I have discussed that is the free energy change and EMF, that is equal to minus delta G is equal to NF E cell. E cell. Now free energy change and equilibrium constant means ln K. ln K. What is the relation between two? Then that is the delta G plus change in free energy, standard free energy, change in standard free energy is equal to minus RT ln K. Minus RT ln K. Very important relation. Delta standard delta means change. You remember, in thermodynamics always you are giving importance for the change. Absolute values are impossible because absolute value you can't determine. That's why always how much change took place from initial state to final state in any process. What was in initial, what happened in final. Then difference, that is actually delta. Then in thermodynamics, we are interested only in you can say change, not in absolute value. That's why always we are using delta, change in any term, change in free energy, change in enthalpy, change in internal energy, correct? Delta change, that is a delta. Change means delta, okay, difference. Then here delta G, change in free energy, standard free energy is equal to minus RT ln K, where K is equal to equilibrium constant. If you are writing C, then you are talking about equilibrium constant. If you are writing only K, then that is you are telling about the same equilibrium constant, but not at these things. Kc, that is equilibrium constant. K is denoting for equilibrium constant only. Okay, but sometimes that K you can consider for any, if it is not in a standard this equilibrium condition, that time also K you can denote. Okay, then generally K means equilibrium constant. Kc value is fixed. Then here delta G, standard delta G is equal to minus RT ln K. Now another important point I am going to discuss. Predicting products of electrolysis. After the electrolysis, what will be the product? That is very, very important question. How will you predict products of electrolysis? Question is asked. Now I am telling you, when an aqueous solution of an electrolyte is electrolyzed, if the cation has higher reduction potential than water, cation, if cation has higher reduction potential than water, cation is liberated at the cathode. Means cation means positive, it will go to the negative. Cathode is negative, you remember. Then cation, if cation has higher reduction potential than water, cation is liberated at cathode. That is in the electrolysis of salt of copper and silver. Correct? This is the example I am telling you. In the electrolysis of salt of copper and silver. And if cation value is less, or otherwise you can tell, then what will happen? Otherwise H2 gas, due to reduction of water, it will deposit, it will liberate. Again you listen. When an aqueous solution of electrolyte is electrolyzed, if cation has higher reduction potential than water, cation is liberated at cathode. Otherwise H2 gas, due to reduction of water. Example, in the electrolysis of sodium. This is very, very important point I am telling you. This is I told only for cation. Cation, if cation has higher reduction potential than water, only then cation is liberated at cathode. Otherwise H2 gas, due to reduction of water. Now if anion has a higher oxidation potential, if anion has higher oxidation potential than water, anion is liberated anion is liberated. Otherwise, O2 gas due to oxidation of water. Again, I am repeating. If anion has higher oxidation potential than water, anion is liberated. Anion is liberated. As for example, bromide ion, iodide ion. Otherwise, O2 gas due to oxidation of water, as in case of fluoride ion. Okay. If an ion has higher oxidation potential than water, an ion is liberated like bromide and iodide. Otherwise, oxygen gas due to oxidation of water. Okay. Example, in case of fluoride ion. Fluoride ion in this case is different. Here, value if you will check in oxidation potential, then this is less. Bromide ion and iodide has a higher oxidation potential, but higher oxidation potential than water, but fluoride ion has less. That's why here this in case of bromide and iodide ion, which has higher oxidation potential than water, an ion is liberated. Otherwise, oxygen gas due to oxidation of water. Example, in case of fluoride ion. Now I am going to discuss about cells, primary cells, secondary cells, fuel cells. Question is asked. Primary cells are those which cannot be recharged. That is a dry cell and mercury cell. This is the example. Primary cell are those which cannot be recharged, means use and throw. Use and throw. Dry cell, example is dry cell and mercury cell. After the use, you will not recharge. You will throw it. Use and throw. Only one time you can use. Now, what is a secondary cell? Secondary cells are those which can be recharged. Which can be recharged means you can use many times. Example, lead storage battery. Lead storage battery and nickel cadmium cell. This, if charge is finished, again you can recharge. That is called secondary cell. What is the fuel cell? Fuel cells are those in which energy produced from the combustion of fuels can be converted into the electrical energy. Again you listen. This is not common, fuel cells. That question is asked. Fuel cells are those in which energy produced from the combustion of fuels. Here this is important. One side you have to burn the fuel, means combustion of fuels. Then energy will be released. Then that energy will be converted into electrical energy. Example of fuel cell is H2O2 fuel cell. H2 hydrogen gas, oxygen gas, fuel cell. One near the one electrode, hydrogen gas will burn like a fuel, correct? And that will be converted to electrical energy. Here that combustion, in the combustion, after the combustion, whatever energy you will get, that will convert to electrical energy. This is the simple. In a simple way you can understand that Fuel cells are those in which energy produced from the combustion of fuels can be converted into electrical energy. Example is H2O2 fuel cell. Now corrosion. What is the corrosion? Corrosion is the process of change of metal surface into salts like oxides, sulfides, carbonates, etc. due to attack of atmospheric gases. Again you listen. Corrosion is the change of metal surface into salts. So metal surface will convert to salts. Example of salts here which will form on the surface: oxides, sulfides, carbonates, etc. But how it will convert to this salt? Then due to attack of atmospheric gases. In atmosphere many gases will be there. When these gases will come in contact with the metal surface, then in presence of moisture, that is the main condition, only then reaction will take place. Just like water is required to make the solution. If solid you will take, it will not react. When you will dissolve in water, only then both solution, both reagent A and B, as for example, in solution only, solution of A, solution of B, if you will mix, only the reaction will take place. Like that way here moisture is required, metal surface, that is you can tell A, and gases from the atmosphere, that is the B. Then both will react only when moisture will be there. Generally rusting takes place or corrosion takes place in rainy season. Then what is actually corrosion? Corrosion actually is the general term for rusting. In iron we are corrosion in iron. Corrosion in iron we are telling rusting. But other metals also is there. There also rusting can take place. There also corrosion can take place. Just like for understanding I am telling you, rusting can take place. There it will be called corrosion. In general it is called corrosion. Rusting also comes under the corrosion. But this is only in case of iron. But many metals are there. Their surface also can be corroded. Then corrosion is the process of change of metal surface into salts like oxides, sulfides, carbonate, etc. due to attack of atmospheric gases. And here you should know, in a corrosion, which type of reaction takes place? Which reaction is responsible? Then oxidation. In this process, corrosion, oxidation is responsible. Oxidation of metal. As for example, if metal is there, iron, then Fe will convert to Fe2 plus. Fe2 plus, it will lose 2 electron. And that 2 electron will be taken by others. And that metal will convert to reduction, or any other metal who will take the electron will their reduction will take place, and you can tell that will be reduced. Then here main cause for corrosion is the oxidation of the metal. Just I briefed you. Now rusting or rust. What is a rust? Actually in rusting also same things will happen. Okay, any metal, same oxidation is the responsible for corrosion. What is the rust? Rust is hydrated ferric oxide means Fe2O3 X H2O. X, you don't know, X maybe 1 H2O, 2 H2O, 3 H2O, 4 H2O, like that way. Then rust is the hydrated ferric oxide, Fe2O3 X H2O. With that, water molecule will be attached. Maybe 1 mole, maybe 2 mole, 3 mole. That's why X you are writing. Fe2O3 X H2O. That is called rust. Rusting of iron can be explained on the basis of electrochemical theory. How? Now I am telling you. H2O plus CO2, we know H2O plus CO2, it will form H2CO3, carbonic acid, weak acid, H2CO3. Then H2O, actually it will be on the surface of layer. It will be on the surface of layer moisture, correct? Then this moisture will react with carbon dioxide and it will form H2CO3. And this H2CO3 again it can convert into the 2H plus carbon CO3 2 minus. This H2CO3 will ionize. Then it will produce 2H plus carbonate 2 minus, CO3 2 minus. Means H2CO3 will convert to hydrogen ion or proton, you can tell, 2H plus CO3 2 minus. Now after that you can see what happens. At anode site or site, at anodic site, what will happen? That iron which is you can say iron Fe2 plus, Fe2 plus oxygen plus 4H2O. Balanced equation I am telling you. 4Fe2 plus means at anodic site, ferrous will be there. Ferrous. There oxygen will come and moisture will come and it will form Fe2O3 8 hydrogen, 8H plus. Two product it will give Fe2O3 plus 8H plus. Correct? This will happen at anodic site. And at cathodic site, here hydrogen ion H plus, that will take, here again I am telling you one, already I have discussed that at anode I told it is oxidation process. Rusting is or corrosion is anodic, this oxidation process. Actually in the beginning what will happen? Iron Fe, it will convert to Fe2 plus 2 electron, and that Fe2 plus, actually that site where Fe is converting to Fe2 plus, that site is called anodic site, where oxidation takes place. That is called anodic site, and where reduction takes place, that is called cathodic site. Then at anodic site, first iron will lose the electron and iron will, ferrous Fe will convert to Fe2 plus. Correct? Now this actually Fe2 plus, in presence of oxygen and moisture. In presence of, in air oxygen will be there. Then that oxygen, moisture will be also present in the air. That will be in contact with the surface. Air will be everywhere. Then on the surface also air will be there, means oxygen and moisture will be there. Then that reaction will take place. Fe2 plus oxygen plus H2O. Then it will convert to Fe2O3 plus hydrogen ion. balanced equation at anodic side is 4Fe2 plus O2 plus 4H2O. It gives Fe2O3 plus 8H plus. 8H plus. Then this two-step reaction takes place at anode. Two-step means Fe converted to Fe2 plus. First step, important step, and it has lost 2 electron. It has given 2 electron, and only there this Fe has reacted with oxygen and water, and it formed Fe2O3 plus 8 hydrogen. 4Fe2 plus 4Fe2 plus O2 plus 4H2O. It gives Fe2O3 plus 8H plus. And Fe, 2Fe, actually when it will react, then it will give 2Fe2 plus. First step or simple way, keep in mind, Fe will release 2 electron and it will give Fe2 plus, that you remember. Then at anodic 2-step reaction is there, and at cathode also 2-step reaction is there. Then what will happen? That electron lost by iron at anode, that will come near the cathode, and it will take at cathode. What will happen? Hydrogen, which was liberated, hydrogen ion, which was at cathodic side, that will come to the anodic side. Correct? There H plus will take electron and it will convert to metal. H plus 1 electron, 1 H means atom is formed. If 2H is there, then 2 electron it will take, then H2 gas will form. Then like that way, if you can say how many H2, that depends how many electrons are there. 1 electron means only 1 H. 2 electrons and 2 H is there, 2 H plus 2 electron, then H2 gas. Like that way 8 H plus is there, 8 H plus, then 8 electron is required. 8 electron is required to neutralize, then it will form 4H2, like that way. Then at cathode, reduction takes place, means hydrogen ion will take the electron and it will convert to hydrogen gas. Correct? And now we have seen that at cathode, what happened? Not at anode, hydrogen ion was H plus was formed, and at cathode that H plus has taken 1 electron and converted to H atom. Then if 2 electron is liberated, means 2 hydrogen is required. Correct? Then finally it will form H2 gas. 1 H means half H2. 2 H means 1 H2. Like that way, how many electron it has released? All electron will be taken by the H ion. I told you if 4 electron was released, then 8H will take 8H plus will require 8 electron. Only then it will be neutralized and it will form 4H2. If 4H is there, then 4 electron is required, then it will form 2H2. Then that will take place at cathode. At cathode, reduction takes place, and at anode, oxidation takes place. Correct? Then what happens? One more thing to understand, that hydrogen ion, it is produced at anode, and if oxygen will come, then what will happen? Then hydrogen and oxygen both will react and it will form water. Correct? Hydrogen and oxygen means 4H plus O2, it will form 2H2O, because this oxygen will be where? It will be on the surface of the metal. Then all reaction what I told you, one side it will behave as a metal, one side will behave as a anode, other side it will behave as a cathode, according to the situation. Correct? Then this oxygen may be present on the surface, or you can say dissolved oxygen. In water also it may be dissolved oxygen. Then in that case, hydrogen is also formed at anode, at cathode, hydrogen gas is formed. Correct? Oxygen is everywhere present. Then hydrogen and oxygen, it will form water, H2O. Then you understood that for the reduction, oxidation is responsible. At anode, oxidation takes place, and at cathode, reduction takes place. At anode, Fe plus 2 electron is released in case of iron, and this actually iron is used where? Near the cathode. This iron is used, correct? Because near the cathode, H ion will be also there. H ion will be there, that will use, and it will form hydrogen gas. Then at cathode, both are there, hydrogen gas and oxygen gas. Then it will form H2O, water. Now, factors which enhance corrosion. Corrosion means what are the factors? Factors which enhance corrosion. You should know, because you want to stop corrosion. Corrosion is destroy all, you can say, metal. All type of metals it will destroy. Then we should know factors due to which corrosion takes place more. Then first factor is presence of impurities in the metal. I told you that on the surface, one side it functions as an anode, other side at cathode. Then actually where impurities will be mixed with metal, that point will work as cathode, impurities. Then first factor is impurities, presence of impurities in the metal. Correct? Pure metal do not corrode. You remember, if metal is pure, then there will be no corrosion. It will not corrode. And if impurity is present, only that metal will corrode. Means corrosion will take place. Then impurities is the first factor. Impurities in the metal. It will increase the corrosion. Second, presence of moisture. Already I told you. In rainy season, generally corrosion takes place. Third important point, presence of electrolyte like saline water. Saline water, actually, if in water, suppose NaCl is mixed, KCl is mixed, some salt is mixed, then that is called saline water. Then electrolyte, presence of electrolyte function as a saline. Example of electrolytes means all, you can say, all material which produces cation and anion after dissolving in water is called salt or electrolyte. All salt produces cation and anion. Correct? Then these are called all, you can say, ions which has positive and negative charge. They form the salt. Then you can say all material which on dissolution in water produces cation and anion is called electrolyte. Electrolyte means there cation and anion both are present. Then third point is presence of electrolytes. Now corrosion can be prevented. How? Corrosion can be stopped. Corrosion can be prevented by the following method. Okay. First, I am telling you barrier protection by oil or grease layer, paints or electroplating. Suppose you know these are the common things in real life. You might have seen also that any barrier you will put on the metal, like oil, you put the oil, then water will not come in contact. Correct? If oil you will put on the surface, air will not come in contact with the this surface of the metal, then there will be no reaction, then there will be no corrosion. Then oil or grease, same things. Oil oblique grease layer. If you put one grease also, then it will function as a barrier. Barrier between metal surface and air. Between that, this oil or grease comes. Then by that way you can stop the corrosion. Or you have seen painting. If you will put paint on the metal, then there will be no corrosion. Or electroplating. Electroplating means in one metal, if you can say very thin layer of other metal, if you will put, then there will be no corrosion on one metal due to the electroplating. Electroplating, you know that electrode, you know, anode and cathode. Anode and cathode. Then cathode, actually, you know, I discussed on cathode, metal is deposited. Correct? Then same process means cathode you have taken on that on the surface of that can say cathode, that metal is depositing, other metal is depositing. Then everywhere whole you can say surface may be covered with this deposit. By deposit means by other one layer will come for other metals, layer will be deposited on the cathode. That is actually called electroplating. Means on one metal other layer you are putting. Correct? Then by that process also it is possible. And next is sacrificial protection. First I told you barrier protection by the oil, grease layer, paints or electroplating. Second, sacrificial protection by coating the metals with more electropositive metal. With more electropositive metal, as for example, Zn. And this is called actually galvanization. Question is asked. Sacrificial protection by coating the metal with more electropositive metals, as for example, zinc, Zn, is called galvanization. If zinc you are putting, then that time it is called galvanization. Then why this word came, sacrificial protection? Then here this Zn will sacrifice for the metal. Suppose iron was there, you want to save the iron. If you will put the Zn layer on the surface of iron, then in the place of iron, corrosion will take place in zinc, not on the iron. That's why name has been given sacrificial. Okay, Zn sacrificed for iron to save the iron. Like that way, any other metal which is sacrificing, like magnesium. Magnesium also same things, it will sacrifice to save the other metal. That's why process is called sacrificial protection by coating the metal with more electropositive metal. Metal which you are putting as a layer, that should be more electropositive than that metal, so that first it will oxidize. Corrosion will take place for Zn, not for the that metal which you want to protect. Third method I am telling you, electrical protection by connecting the iron pipe to a more electropositive metal with a wire. See, this is it's also main just like what I discussed electroplating. Concept is the same, but here wire you will take. Electrical protection by connecting the iron pipe to a more electropositive metal with a wire, with a wire. Okay. Then like a magnesium, I told you, in a ship, generally they will run on the water only. Then there will be chances for corrosion. Then there generally it is used, or pipe, iron pipe is suppose long iron pipe is there, and you want to save that pipe from corrosion. Then this you have to make contact with other wire or other metal. Through wire you can make contact with other metal like magnesium, because now magnesium is more electropositive than iron. Then there will be no corrosion on iron. Iron will be protected. Magnesium corrosion will be, you can say, on magnesium. That is a small block of magnesium you have to take, a small piece you have to put. Then but that should be connected with iron through wire. Then corrosion will take place on magnesium, not on the ferrous. That is called electrical protection. Okay. Electrical protection by connecting the iron pipe to a more electropositive metal with a wire. And now I am stopping only here. Next class again I will continue. I think in next class this chapter may finish. Okay, means review will finish. Thank you.